Hello everyone, welcome to Soldinger's Cat and this is Devabrata. Basically today we will discuss the most important topic of class 12 is basically the modern physics. So here we have three parts. First of one is dual nature of radiation and matter, atom and nuclei, photoelectric effect and Einstein photoelectric equation, particle nature of light, the photon, matter wave and Division gamma experiment, de Broglie wavelength, alpha particle scattering and Rutherford nuclei model of atom, Bohr model and hydrogen spectra, X-rays, nucleus and radioactivity, nuclear fission, fusion and binding energy. And basically the total number of questions are coming in the basically its lectures for the NEET JEE Main and advanced students. In NEET exam in modern physics there are 4 to 5 questions are coming, and JEE Main 5 to 6 and JEE advanced also 5 number of questions are coming in this exam. So very important, and one thing is that I just summarize this topic and solve today 10 problems important, and homework also 10 problems should be given, and after we get time and cover all the topics we just discuss the theory elaborately. So basically our first topic is Bohr model of atom. So here the summary of the so first of one, the Bohr model of atom. Bohr postulate for quantization of angular momentum, that is basically the mvr is equal to nh by 2 pi, nh by 2 pi, where n equal to 1 2 3 dot dot dot. So then h nu is equal to E2 minus E1, for nu is equal to E2 minus E1 by H. As per Bohr's postulate, the radius of different orbit for electron is r equal to n square h square epsilon naught is divided by pi m z square. So r proportional to n square. For hydrogen atom z is equal to 1 and n equal to 1. So r1 for hydrogen atom h square epsilon naught by pi m square, and its value would become numeric value 0.53 Armstrong. So expression for speed of electron in nth orbit, basically the v z square divided by 2h epsilon naught n. So basically v proportional to 1 by n. Energy of hydrogen atom, that for energy of hydrogen atom, the kinetic energy, that k equal to, formally we know, just a minute, half mv square and equal to z square by 8 pi epsilon naught r, and the potential energy U is nothing but 1 by 4 pi epsilon naught z square divided by r, and E2 to become. So after one we just get the total energy here. The total energy would become E, that kinetic energy and the potential energy. So it would become the minus, total energy is negative, z square is divided by 8 pi epsilon naught r. So putting the value of r, we should write first of one that n square h square epsilon naught is divided by pi m z square, we get the expression of energy minus m z square e to the power 4 divided by, we just summarize here, epsilon naught square a square n square, and we get the energy is proportional to the important result minus 1 by n square. So the another one, when electron jump from the higher orbit into and to the lower orbit, higher orbit to lower orbit jump, that basically we get here for jumping of electron for higher orbit to lower orbit. So it's formula number 5, or we just get the value that energy difference daily is equal to E2 minus E1 is equal to m z square e to the power 4 by 8 epsilon naught square a square 1 by n1 square minus 1 by n2 square. So frequency of emitted wave, frequency nu of emitted wave would become that E2 minus E1 by h. So we get the value here, and the wavelength lambda would become that wavelength lambda. For that case we just get 1 by lambda equal to nu by c. So now put the value m z square e to the power 4 by 8 epsilon naught square ch cube 1 by n1 square minus 1 by n2 square. So basically h we get the m e to the power 4 by 8 epsilon naught square ch cube is equal to r is the Rydberg constant, and we get the value of 1 by lambda z square r 1 by n1 square minus 1 by n2 square. For hydrogen atom, that z equal to 1, so 1 by lambda equal to r into 1 by n1 square minus 1 by n2 square. This is our final expression. So basically our next topics is that for the emission spectra of hydrogen atom, basically we have some series that Lyman n equal to 1, n equal to 1, the Lyman series. For n equal to 2 we get Bohr, and for n equal to 3 we get Paschen, and for n equal to 4 we get Brackett, and for n equal to 5 we get Font. So basically, and here for the Lyman series the emission spectra like that, the ultraviolet, and for ultra, and this is for visible, and this is for infrared, and for bracket series here also with the infrared, and this one the emission spectra of hydrogen atom. And here we just get for ultraviolet part, the Lyman series would become for n1 1 and the n2 is 2 3 4 dot dot. So basically we just get the result, the 1 by lambda is equal to r, for this is for the Lyman case, 1 by 1 square minus 1 by n square. So you just do all the series, like for Bohr is equal to r, here just 1 by 2 square 1 by n square, and this is for ultraviolet and this is for visible, and third case is Paschen. For Paschen series 1 by lambda is equal to r 1 by 3 square minus 1 by n square, and this is for the infrared. And fourth one is the bracket series. For bracket series 1 by lambda equal to 1 by 4 square minus 1 by n square, and the n here n should be 2 3 dot dot, here n should be 3 4 dot dot, here n should be 4 5 6 dot dot. Here it would become that the value of n 5 6 and dot dot. So this is our series here. And binding energy of electron. So binding energy means that the minimum energy required to separate proton and electron, and the ionization energy, minimum energy required to just ionize the atom, corresponding potential, each ionization potential, and we just get the excitation energy in nth level, basically the del E, nth level energy En minus E1, first one. So our next topic is that the photoelectric effect. So basically here we just write some equations. First of one, that the very important, if E and P be the energy and the linear momentum of a photon of light, we just get equal to h nu is equal to hc by lambda, and P equal to h by lambda, and equal to E by c. So E energy of photon is basically Pc. So maximum kinetic energy of photoelectron, basically we just get for the Einstein photoelectric equation, K max is equal to hc by lambda minus phi is equal to h nu minus phi, where lambda naught is equal to threshold wavelength is equal to hc by phi, and the corresponding frequency is called the threshold frequency, defined as nu naught equal to c by lambda naught is equal to phi by h. And so our expression in compact form would like become K max equal to h nu minus nu naught. So stopping potential in cathode ray tube experiment, that here this is axis of 1 by lambda, and this is for the nu naught, and this one is the line. So slope would become hc by e, and this is basically phi by e. So basically here the threshold voltage and the stopping potential would like that V naught equal to hc by e 1 by lambda minus phi by e. So we just get to graph here for the intensity constant, and another one, this is for the intensity constant, I constant, the graph would like that, this one. So here is the I versus V, and the condition that nu 3 basically greater than nu 2 greater than nu 1, and for frequency constant it would become this one. So for frequency constant it would become like that. This is a point separate two region, just like that. For frequency constant, this one is I1, I2 and is I3, and this is the I origin and the V. So basically here I3 is greater than I2 and greater than I1. So our next topic is that this is for the 3 and the force exerted in a mirror by incident radiation. Basically the formula F equal to 2u by c, where u is radiant energy falling per second for perfectly refracting, and for oblique incidence the force would become 2u cos theta by c. This is for oblique case, this one, this, and this is theta here. So for perfectly reflecting mirror we just get that the F NEET u by c 1 plus rho, where u is the radiant energy falling per second and rho be the reflection coefficient of mirror, is defined as ur by c. For perfectly refracting, rho equal to 1. For perfectly absorbing, this is for absorbing and this is for reflecting. Perfectly refracting and perfectly absorbing, and the variation of electric field with incident radiation, this is very important for JEE Advanced, equal to E naught sin 2 pi by lambda Ct minus x. And another topic that basically we have the another one, the de Broglie wavelength we have no for photon p equal to h by lambda, and lambda is equal to h by mv. So p equal to mv for a particle, and m be the relativistic mass of the particle, so it would become m equal to m naught 1 minus v square by c square to the power half, where m be the relativistic mass of the particle. And the distance of closest approach, the second important parameter, that is the distance for the closest approach. So basically here is alpha particle, this is a nucleus, and is alpha particle along this axis, this one is, just a minute, this one is bombarding the alpha particle here, and this charge 2e. So impact parameter, that going in velocity v, so this is JE, and this from center of mass distance, the r naught. So energy equation, that half mv square kinetic energy plus potential energy after kinetic energy plus after potential energy, as it is raised, so this would become 0, and 4 pi epsilon naught Coulomb force 2z square is divided by r naught. So basically we have get the value of r naught is 2z square by 4 pi epsilon naught half mv square, where r naught is basically proportional to 1 by kinetic energy. So impact parameter, this is another concept, impact parameter, and defined as by b. So b would become, b is equal to jd square by 4 pi epsilon naught half m v square cot theta by 2. So what is theta? Theta just become this scattered alpha particle with along this cone is basically defined as the theta, and theta is the here the scattering angle SCATT, theta be the scattering angle, and for impact parameter b equal to 0, theta would become 180 degree, and b equal to infinity impact parameter, the theta would be 0 degree. This is special case here, we just discussed here the impact parameter. So our next topic, that the X-ray. So basically first of one, so collide tube method. So basically for electron bomber, the intensity versus I versus lambda would become like that. So this is basically lambda c, and this is the lambda beta, and this is the lambda alpha, this is the k beta and k alpha part. So basically continuous curves represent, this continuous curve represent the continuous X-ray. So kinetic energy of electron is ev, here kinetic energy ek is ev. So daily energy convert into the X-ray photon, that daily would become hc by lambda, and the lambda is equal to hc by daily. So daily is equal to 0 is imply that lambda is infinity, no X-ray, and daily equal to ev is imply that lambda c, that is hc by ev, this is cutoff wavelength. And the important point is that k beta X-ray more energetic than k alpha. So k beta energy is greater than k alpha energy. So cutoff wavelength equation, lambda c is equal to hc by ev. So cutoff wavelength of X-ray is very important formula. Cutoff wavelength of X-ray is lambda c 2m c lambda square by h. So propagating of X-ray through a medium, propagating of X-ray through a medium, this is another important concepts. So minus di dx is equal to mu I, where mu is the absorption coefficient of X-ray, and it would become, after integrate, I equal to I naught exponential minus mu x. So I by I naught is equal to half to the power n, half to the power eta, where the eta would be the x by x naught. And the another one is the Compton effect. So basically for that reduction, that X-ray scattering by stationary electron, this is stationary electron and scatter here this one, and this is the scattering, and this angle is phi, So basically electron here momentum p equal to h by lambda, and x-ray beam, so energy is equal to hc by lambda. So basically here we just get the relation energy related p square c square plus m naught square c to the power 4, and increase in wavelength of scattered photon, the Compton effect equation, very important, lambda dash minus lambda equal to del lambda h by m naught c 1 minus cos phi. So m naught is the rest mass of electron, and h by m naught c, this is h by m naught c, this is basically the Compton wavelength, and basically for phi the scattering angle. So one important topic for the JEE advance, first of one, for phi equal to 0 degree, here we get cos phi equal to 1, so lambda dash is equal to lambda. For second one, phi equal to 90 degree, we get cos phi here 0, so lambda dash minus lambda is equal to del lambda h by m naught c, and for phi equal to 180 degree, we get the value of cos phi equal to minus 1, so lambda dash minus lambda is equal to 2h by m naught c. So this is the Compton wavelength, and that is the maximum increase of wavelength. Another topic is very important, that MCQ, Moseley's law. Basically this is a origin, and this is the graph, this is for root nu, and nu be the frequency of k alpha x-ray, z is the atomic number, and nu versus lambda. So basically we have here a b constant, and the law derivation is the root over nu is equal to a into z minus b, where a and b are the constant, and a constant would become root over 3 rc by 4, where b is equal to 1, and we just plot here, and the lambda a 1 by lambda a is equal to 3r by 4 z minus 1 whole square. And another important, this is position number of element, this is root nu, and in the x-axis position number of element, positions number of element. And another important topic is the Bragg's law. Bragg's law for the crystals, that this is theta and the theta, 2d sin theta is equal to n lambda, where n is the integer and d is the distance here. So our next topic is basically the radioactivity. So we just discuss for the nucleus and nuclear phenomena. So X, A and the Z, where the Z is the atomic number of proton, A is the mass number of nucleus. So number of neutron, N is equal to A minus Z, and the rest mass of the nucleus, is equal to m naught, m zxa minus zme, and the rest mass energy of nucleus, rest mass energy basically the rest mass energy daily mc square. So m mass of jet a jet x a minus z me into c square, and the nuclear radius is equal to r naught a to the power 1/3, where the r naught value 1.1 into 10 to the power minus 15, where a is the mass number, and the binding energy would become Be, that ZMP plus NMN minus mass of nucleus into c square, basically del m c square. M is the mass of the nucleus, Z is the proton, and N is the neutron, and C is the speed of light. And the radioactivity decay for the alpha decay, that ZXA by decaying just Z minus 2 atomic number and the mass number decrease by 4, and 2 helium. And the beta decay, there are two type, that for beta, so first of one is beta minus is basically the ZXA to Y, Z plus 1 A plus beta minus plus nu bar, and the beta positive decay would become ZXA Y decrease 1, so Z minus 1 A plus beta positive emission of nu. So similar process known as the electron capture. So electron capture process ZXA plus E, this is electron captures like that, Z minus 1 Y A plus nu electron capture. So laws of radioactivity decay, the rate of decay, laws of radioactivity decay. So the rate of decay minus dN dt is equal to the lambda n. So we just get n equal to n naught e to the power minus lambda t. So where lambda is decay constant and n naught is the number of active nuclei t equal to 0, and for a should be a equal to a naught e to the power minus lambda t. This is for the activity of the sample, So half life t half would become ln2 by lambda, basically 0.693 divided by lambda, and the activity at time t, the activity A is defined by A equal to A naught by 2 to the power T by T half, and the lambda would become 2.303 by T log base 10 n naught by n, where n naught is the initial number of atom and n be the number of atom after time t, and the average time t average, it would become 1 by lambda, basically the S by n naught is equal to 1 by lambda, and basically after that we just get t average value t half by 0.693. So here we just conclude all the summary of the chapter modern physics, and after we just go through the problems. So first problem is coming in NEET exam, recent exam 2024. This says that the graph which shows the variation of 1 by lambda square and its kinetic energy is E, what the graph should be the correct. So basically we have the lambda is equal to h by p. So h by root 2 me. So lambda square we just get h square by 2 me and 1 by lambda square. So reverse 2 me divided by h square. So 1 by lambda square is proportional to energy. So this is basically proportional to energy. Basically y equal to mx passing through origin. Y equal to mx passing through origin. So D would be our correct answers. Second one, quick. So second problem coming in JEE Main 2023, the energy level of an atom is shown in figure. Ground state, first excited, second and third, fourth. Which one of the transition will result in the emission of photon of wavelength 124.1 nanometer? So here basically we given the lambda and we just calculate the energy. We know the energy equal to hc by lambda. So put this value is 6.626 into 10 to the power minus 34 and c speed of light 3 into 10 to the power 8 by lambda 1.124.1 nanometer is equal to 1.24 into 10 to the power minus 7 meter, and this would become in joule. You just convert joule to electron volt, you get 10 electron volt. So energy of photon in transition D E dash is equal to 0 minus 10. So basically 10 electron volt. So 10 electron volt energy. So here shown that from D to E A, this is basically del E is 10 electron volt. So D transition would be the correct, option C would be the correct. Third one, NEET is saying that in hydrogen spectrum the shortest wavelength in the Bohr series is lambda, the shortest wavelength in the bracket series would what? So I just write that here 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. So shortest lambda of Bohr series, that n1 equal to 2 and n2 is equal to infinity, the shortest, and just put this value here, we get that 1 by lambda is equal to r 1 by 2 square 1 by infinity square. Basically we just get r by 4. So here we get r equal to 4 by lambda. So another one, the shortest bracket series, this is for the Bohr, and this is for the Bohr series, and for the bracket series that n1 is equal to 4, I just write. So all the questions are coming my summary lecture of the topic. The formula is very important, so I just first discuss all the summary paper. So all the problem you just see coming in the same type, I just write in the first one. So the lambda b bracket is basically r 1 by 4 square minus 1 by infinity square. You just calculate and get the value r by 16. So put the value of r, we get 4 by lambda. So basically 4 by lambda divided by 16. So 1 by lambda b is equal to 1 by 4 lambda. So lambda b imply lambda b equal to 4 lambda. So 4 lambda would be our correct answer. Option A is correct, 4 lambda. Quick. Fourth one coming in JEE Advanced. JEE Advanced, the photoelectronic material having work function lambda naught is illuminated with light of wavelength lambda. The fastest photoelectron has a de Broglie wavelength lambda d. So basically a change in wavelength of the incident light by del lambda result in this change del lambda d in lambda d. So ratio of del lambda d and del lambda is proportional to. Basically we just hear the Einstein equation, and del lambda is small change. So small change basically the differentiation. You just keep in mind and pause this video and take carefully the questions. We have no time here. We just calculate according to the photoelectric equation. We just get the Ek max is equal to Hc by lambda minus phi. So we get the kinetic energy P square by 2m. Put this value. So Hc by lambda minus phi naught, the stopping potential, and put P equal to h by lambda. So h by lambda d P square, put h by lambda by 2m is equal to Hc by lambda minus phi naught. So here given this line is very important, that the del lambda means the, here del lambda means the d lambda differentiation. So assuming small change, differentiating both sides. Now differentiating both sides, that a square by 2m is constant outside, and the differentiating here d lambda d divided by lambda d cube is equal to minus hc by lambda. You just differentiate both sides, and or the d lambda d by d lambda is proportional to lambda d cube by lambda square. So you just differentiate both sides and get the result lambda d cube by lambda square. So lambda d cube by lambda square, d would be our correct answer. Go ahead, our fifth one. A nucleus of mass 189 split into the two nuclei having mass number 125 and 64, the ratio of the daughter nucleus. Basically we have here know the equation r equal to r naught a to the power 1/3. So r1 by r2 is equal to a1 by a2 to the power 1/3. Put this value 125 by 64 to the power 1/3. You got the result 5 by 4. So coming in NEET 5 by 4, B option is correct. So sixth one coming in JEE Main, they are saying that in the given nuclear reaction the approximate amount of energy released will be what? This is given, so you have to find the energy released. Basically we just write here the del mc square. So first the mass defect del m is equal to m of 92A238 nucleus, m of 90B234 minus m of 2 helium atom, so 4 into d. So this is mass defect. Put this value here given 238.05079 minus 234.04363 minus 4.00260. You just calculate and get 0.004564 mu. So energy release is basically the formula del m c square. Just put this value del m in c square, so 0.00456 and c square in MeV is equal to 931.5 mega electron volt. So after calculate you just get 4.25 MeV. So 4.25 D would be our correct answer. Next one coming in JEE Advanced. So JEE Advanced problems, a metal target with atomic number Z equal to 46 with bombard with a high energetic electron beam, and the emission of X-ray for the target is analyzed, and the ratio R of the wavelength is K alpha line cutoff found by R equal to 2. K alpha line cutoff found in R equal to 2. The same electron beam bombard another metal. What value of R? R basically the cutoff found in this state. So basically we just write the formula. So our summary of the topic is very important. So all of our questions coming in NEET JEE Main and Advanced, we just solve by approaching our summary lecture. So our summary lecture or summary chapters or topic is very important. We just write all the formulas and the concepts here, and after completing all the topic we just discuss the theory elaborately. So here the problem should be done with our summary lecture formula. So basically here that the given the 1 by lambda is equal to RE Z minus B whole square 1 minus N1 square minus 1 minus N2 square. So since voltage across the X-ray tube is constant, so lambda naught will remains constant. So basically here we just get the value here, get for 2 lambda naught is equal to RE given that 46 here minus 1, just put the value 1 square minus 1 by 2 square. This is equation number 1. And the another one we just find here the R equal to 2 given, we just put 1 by R lambda, 1 by R lambda, and here R dash lambda, R dash should be found. So RE 41 minus 1 whole square 1 minus 1 whole square 2 square. So this is our equation number 2. So now we get the 1 divided by 2, that just divide, we get R dashed by 2 is equal to 45 whole square by 40 whole square is equal to 81 by 64. Calculate with numeric value 1.27. So R dash our become 1.27 into 2, so basically 2.54. So 2.54 nearly equal to, so 2.53 our answer, option A would be the correct. So our next questions in NEET exam, most important questions. So a photoelectronic surface is illuminated successively by monochromatic light of lambda and lambda 2 if the maximum kinetic energy of the emitted photon in a second 3 times of the first case. So we have to find the work function. We just here the same, the energy equal to K max plus W. So K max would become E minus W is basically H nu minus W. So K max Hc by lambda minus W, this is equation number 1, and 3 times, so 3K max would become Hc when lambda is half minus W, this is equation number 2. We just divide equation 1 by 2 and get W. The work function is Hc by 2 lambda. Work function is Hc by 2 lambda. A option would be the correct. So our next coming in JEE Main. So here which figure shows the correct variation of applied potential where I1 less than I2. I just draw this in our summary lecture. Given since I2 is greater than I1 signifies that the saturation corresponding to I2 is greater that of I1. Saturation of I2 saturation is greater than of I1. Basically here intensity is greater. So we just draw this graph. B would be our correct answer. Last one coming in JEE Advanced. This is very important. One or more answer would be the correct. This is called the MSQ type questions. for photoelectric effect and incident photon and wavelength lambda. So you just which graph should be the correct for the lambda naught with lambda and 1 by lambda. And I just solve the ninth problem in here. So basically MSQ type JEE advanced, you just try to solve. I just give you for your homework. We have 10 homework and I also include, because for your better understanding and better concept, I just hints you that you just here you use the Einstein photoelectric equation. EV naught is equal to hc by lambda minus w, basically where V naught is equal to hc by E 1 by lambda minus w by E. So V naught versus V and V naught versus 1 by lambda and lambda. For 1 by lambda you just write y equal to mx minus c. So mx minus c, this one c, and for lambda at this is basically for lambda hc by, I just do here. So lambda equal to lambda naught. For lambda you just try to think, and I should, this is the decay, this is the decay here, decay for lambda, for that. So I should, A would be a correct. A and C, the MSQ type question should be correct. So I usually do homework for your better understanding, and I have just 10 homework for you to, you just solve it for your better concept and understanding. Just pause this video and take a screenshot. First one, this is first one, first two, first three and first four. You just pause 3 seconds and take a screenshots. Second one, question number 5 to 10, 5, 6, 7, 8, 9, 10. These all are coming in JEE Advanced, JEE Main, NEET. Just pause the video and take a screenshot. Leave this page. Last but not the least is basically our contact. You just solve all the homework in your home. And if you need the study material of our YouTube lecture and some study material relating to the NEET and JEE Main, you just mail in this ID catschrodingers1935@gmail.com, and I just try to teach you the all the class 11 and 12 JEE Main advanced and NEET aspirants, and for BSc and MSc IT JAM, JEST, TIFA, CSI, NIT and GATE. Basically, last but not the least, thank you very much. Stay happy and well. Goodbye. Take care.